We'll be optimizing some equations today, and what that means is I want to have this is called my objective equation. And my objective equation is the thing that I want to make small or really big. And these right here are my constraints. So they're equations that limit me to my choices of points that I could use. So this would come in if I wanted to minimize, say, a cost, if I was running a business, or perhaps a profit. Maybe I want to maximize my profit if I'm running a business. So this first one I'm going to do by graphing. So I'll take that first constraint and I'll go ahead and solve it for y. So I'll subtract the x and I'll divide by 2. Don't forget to have the x there. And I will go ahead and graph. Now I don't need these quadrants right here. So when we're graphing, we're going to want to take a look at all our constraints. So I'm taking a look at these constraints, and I know that my answer is not going to be negative x or negative y, so I don't need these other quadrants. So always take a look at all your constraints before you start graphing. So my y-intercept is 3, and my slope was down 1, right 2. And I'll go ahead and use my line tool. And there's my first equation. Okay, my second equation is these. I don't need to solve for anything. So x is greater than 2. So I find 2. And this is a vertical line, so I'll go ahead and get that. So there's x is greater than. Now I didn't shade yet. But that's because I don't want this graph to be too messy right away. And next is y is greater than 1. So I find 1, that's right here. That is a line. Now if I were to shade this, what I would find is that for the first one, and I'll just use like a light gray right here. For the first one, I am shading below, so I shade below this line. Then I'll use a dark gray. To the right of x equals 2. And then above y1, and we see this is my area. So this is my feasible region. That's called the feasible area, meaning all those are possible answers. Now since I do have equal to, I have these points. And where all my graphs meet, those are going to be called my critical points. And generally my answers are one of these points, so I need to figure out which one. So the first point, this point right here, is the point 2, 2. So one feasible point is 2, 2. This point is 4, 1. So there's another feasible point, or a critical point. And this point is 2, 1. So these are my feasible points, or critical points. Critical points. And I am going to test them into this equation and see which one gives me the minimum value. So c equals 3 times 2 plus 4 times 2, 6 plus 8, 14. The other one, 3 times 4 plus 4 times 1, 12 plus 4, that is 16. So I know it is not that one because it's not a minimum. And then c equals 3 times 2 plus 4 times 1. So that's 6 plus 4, which is 10. So I know it's not that one. It is this one. So my minimum value comes from x equals 2 and x equals 1. And the minimum value is 10. Okay, let's try another. I will again do this by graphing. So I'll set up my graph first, and I can see from right here that these restrict me to positive values, so I do not need the negative portion of my graph. So I won't even set that up. So I have in essence already dealt with these two equations. I know that I'm in quadrant 1. So I won't bother graphing them. I know I'm over here. So I'm going to worry about these two. So I'll solve for y. And I'll solve for y here. And I do see that I'm looking for a maximum this time. So this might be a profit, hence the p. So y-intercept of 6, 1, 2, 3, 4, 5, 6. And down 1, right 1 for my slope. Go ahead and get that in. And I will shade it on time this time. So this one's below. Nope, I did not want to do that. I want to use this tool. Okay, that's better. And then this one, at 10, I'll use a different color for that one. So 10, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then down 2, right 1. So this is going to be one of my critical points right there. And go ahead and get that. And this is also below. So this right here is my feasible region. So I see right here, at the edges of my feasible region are my critical points. So, what are my critical points? Well, it looks like I have 0, 6. Looks like I have 4, 2. And looks like 1, 2, 3, 4, 5. Maybe? 5, 0. Now I want the maximum that I could get from my equation, so I put these into my target equation. And let's see here, p equals 4 times 0 plus 6. So 6. So this one gives me a 6. This one, what does this one give me? So p equals 4 times 4 plus 2. So 16 plus 2. 18. So I know that this one's not the answer because it wasn't the maximum. P equals 4 times 5 plus 0, 20. So this one gives me 20. So this one's the answer. So what's my answer? I would say that the maximum is at 5, 0 with a value of 20, because that's what I get in my objective equation. Okay, let's try one more. Now these could come in the form of word problems, so you might need a bigger or smaller graph depending upon the context. I see again that this is going to limit me to quadrant 1, so I'll use that in order to set up my axes right here. I don't need any negative values. And I'll solve both of these for y. So 2y is less than or equal to negative 4x plus 4. What did I do? I solved this by subtracting 4x. Divide by 2. Now remember, when we divide by 2, everything, this is going to apply to everything. So y is less than or equal to negative 2x plus 2. And this is below, so I will graph below this line. Y-intercept of 2, down 2. Okay, and we'll go ahead and put this line in. and that is below the line. Wow, that's a really small feasible region there. Alright, the next one. 2x plus 4y less than or equal to 4. Subtract the 2x. This is the plus, it's not written. Divide by 4. Less than or equal to negative a half, because that reduces to a half, plus 1. So I'll do this one in orange. My y-intercept is 1. Then down 1, right 2. So this is very, very small right here. Very small. In fact, it is so small, kind of hard to see what's going on here. But we do have a point right there. I wonder what that point is. Okay, because we are going to need it. Well, let's find our feasible regions right here. I darkened it in. So this point is the point 0, 1. And this point is the point 1, 0. And I'm going to guess, though I don't know for sure, what is this point? Well, this point is when these two equations are equal. So in order to figure that out, I'd say, well, negative 2x plus 2, when is that equal to this equation right here? Which is negative a half x plus 1. I'll clear my fraction by multiplying by 2. Now it could be that when you're doing this that you know right away what it is because you graphed a lot neater than I did. I'll subtract the 4. Divide by negative 3. So I get 2/3 for x. So if x is 2/3, then what is y? So if x is 2/3, I'll just put that 2/3 right here. Cross cancel. So negative 1/3 plus 1. So get a common denominator. That is 2/3. So 2/3, comma 2/3. Alright, so I want the maximum for this. So if I put in 0, 1, I get 1. And down here, if I put in 1 for x, I get 3. And if I put in these, well, let's see. 3 times 2/3 plus 2/3. So this is going to be 2 plus 2/3. So that's 2 and 2/3. It looks like this is the one, so these others are not it. Alright, that's it. Graph neatly in order to do these.